Mobile operation, HF mobile, VHF mobile. It's a great opportunity to get outside and look at your hobby from a slightly different perspective. Lots of advantages, but of course there's also lots of decisions to be made. So in this video, I'm going to lay down some of the basics I think you need to consider from my own personal experience. Welcome back to the Waters and Stanton video channel. My name is Peter Waters and my ham radio call sign is Golf 3 Oscar Juliet Victor. Mobile operation. You know, I've been interested in mobile operation for an awful long time. This book here, the camera will focus on it, which I purchased from the ARRL in 1959, $2.50. $2.50. But you know, the interesting thing about this book is that there's still a lot of relevance in here. Now, of course, a lot of the equipment, in fact, all the equipment was valve based, which was a bit of a problem in those days, operating valve equipment from a car, because you had to have an HT line, about 200, 300 volts, which in itself was a bit of a problem. And it was rather conventional then to run the gear from the vehicle battery. Quite a strain on the battery, actually. I suspect that there's quite a few hams that got stranded due to the hobby of ham radio. Anyway, things have moved on, and I'm going to talk about mobile operation, particularly HF mobile operation. By and large, VHF operation is fairly straightforward. There's plenty of equipment currently available for mobile. It tends to be short range. The antennas, there's a lot of antennas around. They're full-size antennas, fairly efficient, or pretty efficient really. So there's not too much of a problem on VHF. But why, first of all, why do we actually go out mobile? Well, I suppose there's lots and lots of reasons. First of all, because you can. It's rather like climbing a mountain. Why do you climb a mountain? Because you can. But there are some other advantages from the ham radio point of view. A lot of us suffer with interference, noise, high noise levels. It's a fact of life now. We can't really avoid it. So it's one way of getting away from the noise and operating in a quieter location. And also, of course, it means to say that you can get out in the open and enjoy the countryside. I mean, perhaps you take your family out with you. Mind you, if you take the family out with you and you want to operate ham radio, you've got to provide some attraction for them, which may mean digging into your wallet a bit. But anyway, that's one of the facts of life. But it is a great way of enjoying ham radio from a different perspective. And there are advantages, you see, because not only can you operate from an environment which is pretty quiet, but often you can operate from an environment that is beneficial to your signals. One of the most obvious, of course, is operating near salt water. It's a well-established fact that operating near salt water, because of the Fresnel zone, will be beneficial to your signal. It's also an established fact that if you operate from a higher vantage point with sloping ground in a particular direction, that also gives benefit to your signal. So there are some advantages from an operational point of view, quite apart from the peace and quiet and the low noise. Of course, in the days when this book was first published, we didn't have much noise. Well, that's not quite true. We did have a lot of noise because cars themselves were noisy. Spark plugs were a real problem. Even for base station operators, every time a car went past, it caused interference, particularly on the LF bands, but that was a different kind of noise. Now we have the ability to get away from it. So let's first talk about equipment for HF operation. There's not too much really around, not current equipment. The FT891 is the favourite for HF operation at the moment. It will deliver 100 watts. ICOM have got their IC7100, it's a bit larger. but it does have a detachable front panel, and that really is it in the 100-watt level. But there's lots of used equipment available. I mean, the old IC706 is still available. That's a great rig for mobile operation. Also gives you VHF as well, and UHF if you get the right model. And you've got the 857 and the 897, both readily available radios on the used market. So there's quite a choice. The only thing that a lot of these radios don't have is an antenna tuner, and I'll come back to that in a bit, an antenna tuner. If you go to a lower power level, if you go to the 10-watt or even 20-watt level, there's some radios around with internal antenna tuners built in. You've got the Chinese G90, which is doing extremely well at the moment. You've got the Elecraft KX2 and the KX3. I was going to say you've got the IC705. Well, you have, but it doesn't have an internal antenna tuner. So there is quite a lot to choose from at the lower power level. At the higher power level, the choice is a little bit more restricted. Do you need high power for mobile? Well, there's certainly an advantage. If you run 10-watt radio, it's pretty frugal on the current it draws, and it'll give you 10 watts output, and you will get some contacts. I've done quite a lot of mobile operation and still do with 10 watts, but I have to confess I do operate CW quite a bit at the time. If you have a 100-watt rig, of course, then you've got a 10 dB advantage, which when you're operating mobile is quite worth having. But then there is the current consumption, which we'll come back to. Why would you need an antenna tuner if your antenna is resonant? Well, it's a valid point. In fact, you don't need an antenna tuner if your antenna is resonant. But the bandwidth of a mobile antenna on the HF bands is quite narrow. On 20 meters, you'll probably get 100, 150 kilohertz. 40 meters, it's going to be below 100 kilohertz. On 80 meters, it's going to be about 40 or 50 kilohertz. And 160 meters, much narrower. So the reason that you need an antenna tuner is to move around the band a bit more. When we talk about bandwidth, we generally refer to the 2-to-1 VSWR point, because that's the point where the transceiver starts to deliver less power. It's protecting itself, so as you go up the VSWR curve towards 2-to-1, the power will start to drop. And it doesn't take long to get to the 2-to-1 point when you're operating mobile. If you have an antenna tuner, there's two things you can do. First of all, you can make sure that the VSWR is always 1-to-1 or 1-to-2 as far as the transceiver is concerned, which means to say it will be delivering the full power. And secondly, you can move around the band a bit more than you could otherwise, because even if you go up to a 3-to-1 VSWR, the loss is negligible, provided that the transceiver can be persuaded to deliver the power into the antenna. And it will do that if you have an antenna tuner. So there is an advantage in having an antenna tuner. It gives you greater ability to move around the band. And you also want to strive for a very low VSWR, because if you strive for a very low VSWR, it means to say you can move around the band a bit more before you get to the 2-to-1 points. Noise from the vehicle tends to be a thing of the past. I haven't had any recent problems with noise from the vehicle. And interference with the vehicle itself doesn't seem to be a particularly common problem. Cars these days are highly complex, but they seem to be fairly immune to RF. I know there are some exceptions, I'm sure, that people will say, oh yes, but I personally have had no problem. I do recall that I had a car about 15 years ago that when I spoke into the microphone on SSB, the rev counter dipped. But that's the only problem I personally can recall. One thing I would say from my own personal perspective is that I don't operate mobile myself in terms of being on the move. I think in today's environment it is particularly dangerous, and particularly on the HF bands, because on the HF bands you're going to have to be tuning around looking for signals and so forth. And sooner or later you're going to take your eyes off the road and who knows what happens. So I don't operate mobile on the move now. I always park up somewhere. I think on the VHF, UHF, probably the argument is just slightly different because you don't need to look at the radio at all. You're channelized and you can be having a chat while you're driving. But certainly as far as HF is concerned, I don't operate while I'm on the move. Let's talk about power supplies for your radio. If you run an external battery, separate battery, it's got a lot of benefit because it means to say that if there was any noise coming up the DC line, you won't have that problem. It means to say that you're not putting any strain whatsoever on your car battery. And with the modern car, it's not that easy to pick up 12 volts DC anyway. In fact, when I lifted up the bonnet of my wife's car a couple of years ago, I couldn't even find the battery. I didn't know where it was. It was eventually found under some plastic cover. But there is a big advantage in using a separate battery. And if you're going to run high power, if you're going to run the 50 or 100 watts level, then you really need to run it from an external battery. And there's lots of options now. Unfortunately, some of these lithium batteries are rather expensive, but it's probably a good investment long term. But certainly, whatever you do, I would strongly suggest you consider using an external battery, particularly if you're going to run at the 50, 100 watt power level. The last thing you want to do is to drain the vehicle battery and suddenly find you can't get back home. Now we come to the antenna, which can cause all sorts of problems if you don't approach it in the correct manner and take certain precautions. Basically, on the HF bands, an antenna is going to be vertical, be a vertical whip, and it's physically very short in terms of its electrical length, particularly as you go on to the lower frequencies. When you're 40 meters and 80 meters, it's a tiny fraction of a quarter wavelength. And it's not until you get to the 15 and 10 meter bands that you start to approach almost full size. And if you have a full size antenna, then it is fairly efficient. One of the problems is that as the antenna becomes shorter in terms of its proportional compared with a quarter wave, the feed impedance becomes lower. And when you get to 80 meters, you can end up with a feed impedance of just 10 ohms, something like that. And even at 20 meters, the feed impedance is low for an antenna that is, say, 2 meters tall. And in fact, most antennas are a bit less than 2 meters tall. So there is a problem there. And the problem is that the antenna is not as efficient as a full-size antenna. And that means to say, of course, that your signal is not going to be as good as it would be if you were transmitting into a full-size antenna. The antenna is highly capacitive reactive, and that's why we have to insert a loading coil. Now, the performance of the mobile antenna is no different from a base station vertical. It is very much dependent on the ground beneath it, in other words, the ground beneath the vehicle. The vehicle itself is a mass of metal, and that helps, but it also is the ground beneath the vehicle that has a significant effect on the performance of the antenna. And as we said, I think earlier in the video, if you park by the side of some salt water, you'll get some benefit because the salt water is great reflector. When we talk about the Fresnel zone, that's salt water is in the Fresnel zone, which has a big effect on the performance of the antenna. There is a very interesting guy who operates pedestrian mobile using a ground coupling system, and basically it's not an antenna tuner, it's a ground tuner. And it's very interesting, actually. There is an article about it on the internet. Basically, he uses a metal plate to couple into the earth beneath the transceiver, beneath the aerial. And that is quite important because it's the coupling of the antenna to the ground that determines what effectively is the ground loss. I mean, to give you some sort of example, I suppose, if you were to park your car beside salt water and you erected a vertical antenna of some sort, you could throw one of the radials or two of the radials into the water and think, well, this is going to be great. The radials in the salt water are going to be really, really good. Well, they probably wouldn't be that good, because you see, RF flows along the surface, and those two radials have got a very, very small surface area, and they'll sink beneath the water. So they won't be doing too much at all. Ideally, you want them to float on the water, but even then, they're still physically very small compared with the surface of the water, which is why if you have some sort of plate that you can couple into the ground immediately below, you get a much better effect. But we're sort of going off the topic slightly. The fact is that a mobile antenna is a very inefficient antenna, and we need to make best possible use of what we have, which is why we need to get the VSWR low so we get the maximum amount of power flowing through that antenna. But of course the power in that antenna is being shared between the radiation resistance and the ground loss, and that is why the antenna is not terribly efficient. But fact of life, that's what it is, and it's what it is and what it is. Now, there are some real no-nos that I've learned over the years from practical experience and from customers coming to premises and saying that the antennas are not working properly. Don't try and mount an HF antenna on a roof rack. It is a real no-no. It causes no end of problems. What actually happens is the roof rack tends to become part of the antenna. The whole thing is not resonant. You can't get the VSWR down. It's an absolute shambles. So don't use a roof rack. It's a very poor method of mounting the antenna. It may look great, but it won't work very well at all, and you'll really run into all sorts of trouble. The modern car doesn't help. I once had a Range Rover and I found that the roof of the Range Rover was alloy, and my wife's car at the moment has got a steel roof, which is great for putting a magnetic mount on, but when I put the magnetic mount on the bonnet to do some photography, I found that it was an alloy bonnet. It wouldn't the mount wouldn't take to it at all. So we are, as cars become more critical in terms of cost effectiveness and so forth, and the use of modern materials, there is a tendency for some of the materials not to be what we expect them to be. Plastic is another example. Fortunately, most car roofs are steel, and I think most hatchbacks are also steel. We seem to have done away with the boot on most cars now, except some big cars, but most cars are hatchback. You can mount an antenna on a hatchback using one of the popular mounts. We do a range of mounts, diamond mounts, and when you tighten it up, there's a little sharp piece of metal on the end of the screw that will pierce the paintwork inside the hatchback and make a metallic connection, and that is quite a good connection. Now you might say, well, yeah, but wait a minute, the hatchback is not very big. You know, I did a video some while back explaining that we shouldn't get too het up with continuity of metal on cars in order to get the best performance, because a good example is the magnetic mount. A magnetic mount on the roof of your car has no DC connection at all to the rest of the car, and yet RF flows through capacity. And the same applies to a car. You mount the antenna on the hatchback itself may well be isolated from the rest of the car. When it closes, it's the capacity effect of that hatchback is quite good, and you will make good use of the rest of the car. And you know, the rest of the car is really valuable. It's a massive great chunk of metal. And sometimes I often wonder if you mounted a vertical down your garden on top of a car, whether you get better results than putting radials along the ground. I don't know. Never tried it. Haven't got a spare car to try it. But it's a thought, isn't it? The other place, the popular place to mount the antenna, of course, is on the roof, and the magnetic mount is a great means of mounting it on there. You do have to be a bit careful because magnets are quite powerful. If you plonk a magnet on the roof, you won't get that magnet off unless you put an antenna on it to lever it off. So do be aware. And if you have the three-way mag mounts, they are really like a limpet. You do need some pressure or some pulling power to get it off. The only thing that worries me about the three-legged mounts now, as good as they are, some of the roofs on cars are very thin, and even a single mount, when you pull it, you can see the roof moving a bit. So just be a bit careful. But yeah, a three-legged mag mount is great because it'll certainly enable you to operate on 42 to well, wherever you want to go to HF. 80 metres, it'll probably work okay on 80 metres as well. 80 metres is not the best band for mobile because the antenna is very, very inefficient. It's the feed point is very low resistance, and therefore the proportion of power going into the antenna is likewise very, very low. So my favourite bands are 40 and 20 metres and going upwards. 17 metres is a lovely band to operate on. The antenna will be quite efficient there. 15 metres, getting better. 12 and 10, of course, you're approaching full size.
One important point is to put a line isolator either at the feed point or near the transceiver. Just a few turns round a ferrite core will do the job.
If we go back to the 60s and 70s, we find that mobile antennas were predominantly centre-loaded antennas. I'm not sure there was any real benefit. I think some have claimed that it's more efficient, but I'm not quite sure of that. I've never checked it myself. But I think the reason for it was primarily because in those days they tended to mount the HF antennas on the bumper of a vehicle, and if you put the coil halfway up the antenna, it was clear of the metalwork of the car. So I think that was probably one of the reasons. Today, almost all antennas are base loaded, although if you look at the diamond range, they do some centre loaded antennas. So I must try that out sometime and see if I can detect any difference. Another thing that I should mention is that when you're adjusting your mobile antenna for resonance, it's so much easier if you have an antenna analyzer. To just rely on a VSWR meter really is not a good idea. And the reason I say that is because an HF antenna can move around quite radically. If you change the whip length, you can easily find it's resonant outside the band. Now, if you're relying on a VSWR meter, you don't know whether it's outside the band at the top, outside the band at the bottom, or just not working. So an antenna analyzer is a great asset because you can immediately see where the antenna is resonant, and it saves an awful lot of time. So if you're starting out, what are the best bands? What are the best bands? Well, I would say 20 metres is a good band because the antenna will be reasonably efficient, and the band is pretty well occupied and open for certainly throughout the daylight hours, and we're coming into the summer anyway now, spring anyway. 40 metres is a good band. The only problem with 40 metres is that the antenna is not so efficient. So I would say 20 metres and 17 metres are quite good bands to cut your teeth on. You certainly get some contacts, even at fairly low power. I mean, I often workstations on 20 metres and 17 metres just with 10 watts. That is no real problem. One thing I would say is if you've got let's say you've got an IC706, which is unfortunately they're a long time out of production now, but there's plenty of them around. If you have an IC706, you might think, okay, well, I'm going to run it off an external battery, and I'll run it at 50 watts or 40 watts to save power. I have found that, and I don't know what the 891 is like, it may be very similar. If you've got a 100-watt rig and you run it at a low power to save battery current, you're not going to save as much current as you might think. I always remember that the 706, even if you press the transmit button with no modulation, no SSB, you're into transmit mode, there was a standing current of about 4 amps. And that was before you transmitted any signal. And when you transmit, say, 10 or 15 watts, you may be drawing another amp, 2 amps. But the whole thing is very inefficient at low power. So if you're thinking of running a 100-watt radio at a low level, just be aware that the current drawn is not proportional to the power. A 10-watt transceiver, like the IC705, is far more efficient to produce 10 watts than a 100-watt radio turned down to 10 watts. And finally, while we're on the subject of antennas, there's a wide range of antennas. There's all sorts of different types. There is one range of antennas that I've always found gives excellent performance, low VSWR, and that is the diamond range. And if you look at the diamond range, you'll find that very often the coils are not wound in a continuous one continuous length. There's a break in the coil, and it reminds me of the days when you used to break the windings on chokes in order to avoid self-resonance. And I just wonder whether diamond make these breaks in the coil winding. It's basically there's a gap in the coil winding and it goes on a bit more. Whether that is to avoid self-resonance. Certainly they work extremely well. And when it comes to antennas, I do favour single band antennas. They tend to perform very well. A multi-band antenna is a bit of a compromise, and I found issues with multi-band antennas. So my antenna now, my standard go-to antenna, is one of the diamond whips. Take a look at them. They're not overly expensive, and I guarantee you'll get a really good VSWR. They're also very easy to adjust. There's like a little clutch arrangement at the top where you just loosen it a bit, pull the whip out a bit or put it back in to trim it onto frequency, and it's that good. I don't like the idea of grub screws, Allen keys and that sort of thing. You drop them, the grub screw falls out, etc. I like the diamond method. It's foolproof. The diamond antenna works, gives you a good VSWR, and it's very easy to adjust. That's my recommendation on antennas. And that really is all I've got to say about mobile operation. I've enjoyed it. I've done a lot of it in the past. Don't do quite so much now, but I've done a lot in the past, thoroughly enjoyed it. And it's amazing. You can be really amazed at what you can work. You might drive to a particular location. I always remember driving to Scotland and getting some reflection off the mountains and working into the States with 50 watts. It was great feeling. You sort of discover these opportunities, you discover these locations that work well for you. And that's one of the attractions of mobile operation. Some guys will try and run higher power. I've heard some stations running 400 watts and so forth. You're into the sort of real serious stuff there. I'm not quite sure about running that sort of power. There's an awful lot of power very near to you. It's like sitting next to an HF antenna that's got 400 watts in it all the time. You think, is this really healthy? The other thing I would say is that I have tried using a single antenna without a loading coil, in other words, using an ATU. It does work. It's the army military style of operation where efficiency is not really so much important as it is to operate and be able to skip around the various frequencies. So the military will use a single whip and they'll whip around the frequencies with an ATU, but it's not the most efficient way of doing it, and I certainly wouldn't use it myself. There we are. So thank you for watching this video, thank you for bearing with me, and thank you for your support, because your support is always very much appreciated, and it's always interesting to read the comments, and some of them are really entertaining, some really witty comments. But there's also some very sensible comments, and there's some very nice comments, which is very nice to read. So enjoy your home radio if you're going to go mobile. Enjoy yourself. Hopefully you've got some good weather coming up now. I'm sure we shall have. And in the meantime, take care. See you in the next video.